Hello everyone, my name is Nate Ferguson and this is Yeast Basics 2, Lecture 1 of 2. So now we're entering Module 2. Module 2 is all about monitoring fermentation, where Module 1 was all about dissolved oxygen and how we get enough oxygen inside of our wort before we hit ferment. We've now progressed into fermentation to figure out what we should be monitoring and how we can adjust our process if something goes wrong. Now, today's problems to solve is as such. Most brewers will pour themselves into hop bills, malt bills, water profiles to a lesser degree, and at the end of all this, just throw yeast at the wort and kind of say, well, I hope it works. This is a mistake, as it prevents you from course correcting or altering the fermentation just to stop something from going wrong. So today, we're going to be exploring the things you should monitor during fermentation, why each one of these things is occurring, and how, if something goes wrong, what you can do about it. Now, the TLDR, or too long didn't read for today's lecture, is if you're not observing it, you're powerless to alter it. A problem that is not seen is a problem that's not fixed. You are stuck with it. Specific gravity is by far the most important metric to measure, but it is by no means the only. There's a lot of breweries that only measure SG. You're doing yourself a disservice. Not all tests that can be done should be done. And this might sound a little hypocritical coming from someone who runs a yeast lab. However, you need to choose a test that makes the most sense based on your brewery's size and risk level. And finally, benchmarkings of your fermentations is very important. Otherwise, you have no idea what a normal ferment is. And you have almost no way to consistently reproduce the same fermentation, or no idea to know what is supposed to be occurring. So, a bit more in depth, the lecture breakdown for today. We're going to go through some general principles of quality control and quality assurance, or what we should be monitoring during ferment. We're then going to talk about time and tank type and why you should be measuring them. You'd be surprised in the breweries that don't. We'll then talk about temperature, pH, and gravity checks, why you should monitor each one. We'll talk about some sensory tests, forced diacetyl checks in process, as well as just general sensory throughout the entire process. We're then going to wrap it up with some other tests and some final common questions. Now, everything for today, and a little disclaimer. The goal of this series is to educate and advise you on the application of yeast in the brewery to avoid common yeast problems. Now, I will be breaking down some of the topics today into their basic components, which will sometimes mean that I simplify concepts or glance over details in an effort to reinforce the point. If you want us to go in more detail, please leave a comment in this section down below. We'll answer those in the Q&A section. Now, a few thoughts for this. I already mentioned this part before, but it's very important to emphasize. I have found a lot of brewers don't monitor fermentation. This isn't a judgment. I didn't do this at first when I first started brewing. However, I realized quickly it was important. No judgment if this is you. Now you have the ability to change it. I've seen, as I mentioned before, brewers spend hours on hop bills, malt bills, dwell on water profiles, and then throw unvalidated, untested yeast at wort and just kind of throw their hands up and say, I hope it works. This is a terrible approach. Now, in some extreme cases, they'll then check the beer for the first time 1 week later and try to determine if it was a success. This isn't great. Now, this approach of doing everything about, say, a week later or not testing things, this is what we would call QC, or reactive QC, or quality control. This is a verification of the final product's quality. What we should be doing, what we'll be talking mainly about today, is what we call proactive or quality assurance, the prevention of defects. If we're not monitoring the substance, we can't prevent or course correct defects away. And this is where I see the very good brewers, shine. Now, quality assurance is all about monitoring something throughout its process. That is how we assure the quality of the product. Now, the goal of the test we'll be talking about today is to help and identify and prevent issues within the fermentation process. That's why we're monitoring them. We're monitoring these things so that we can correct for them. If we're not monitoring them, we have no way if we need to step in and act. Now, being able to detect these problems quickly within the process means you can respond and fix these errors. And this is where I see tons of brewers overlook these steps or not understand why these things are important. Now, Cole's notes for today, another bit. This stuff's not exciting. It's not enthralling. It's kind of that boring, minutia of the day that occurs. But it's also the thing that makes really high quality beer possible, and high quality reproducible beer possible. So, a handful of you have probably already had this jump into my mind. Whenever I see talks like this, is the first that jumps into mind. So I'm assuming you're in the same position. There's usually two questions. The first one is, how much is this going to cost? And the second is, how much time will it take? Now, these are very good questions. These are very important questions. And the answer I have to them might sound a little hypocritical. But based on how you're going to answer these two means that not all breweries should be doing the same tests. This is something we're going to cover a bit more in depth outside of this series, but the Coles notes for this is that you have to choose the right tests based on what you are trying to get out of this. Each test is going to give you increased actionable knowledge, increased ability to intervene in your process at the expense of time and resources. That's the cons. So I'll give you two examples as to when you should and should not do some of these tests. So say you're a 10 hectoliter brew pub that sells most of its product over the bar in pints. Cell counts may not be the most important thing, or in-process cell counts may not be the most important thing for you. The beer is going to move fast enough and be controlled over its life to mean that a lot of the benefits we would see from doing these tests, your product's never going to be at risk of them. You're not going to have a lot of shelf life issues because your beer is probably moving very quickly, and it's not going to be in, say, for us, the LCBO or any sort of central distribution, unrefrigerated and neglected. Now, what you should be doing for a brewery like this is a forced diacetyl test, which is a proactive test or a quality assurance test. Because if the beer tastes like diacetyl, that's bad whether or not it's going over a bar or whether or not it's someone opening up the can from a central distribution of some sort. So you have to choose the tests that are going to have the biggest impact for you. Now let's scale it up. If we are a larger brewery with beer that's in central distribution, should we be doing cell counts throughout fermentation? Well, this will help us ensure shelf life and repitchability. This will help us determine what properties this beer we just produced has, which means that, cell counts are tests that produce high visibility of fermentation. This will allow us more control, and it's going to give us more confidence of this product's performance when it's in the industry. At this scale, more control and fine-tuning and fitness of fermentation are needed to ensure profitability and high-quality product. You have to alter the tests you're doing in your brewery to the risk that your product poses to you. That is a topic we're going to be covering on its own outside of this lecture series. Look forward to that in the future. Now, I also, before we really get into today, want to give a huge acknowledgement. So this presentation today was inspired, I wouldn't say primarily, but it really pushed it to the forefront for me from an article written by Tim Faith of Goose Island Brewing Company for the Master Brewers Association of America's Technical Quarterly. That was a large mouthful. And the article's title is Fermentation Quality Control, including fermentation in your beer recipe. Now, I highly recommend you read this article. This article put a lot of things that I've been trying to say to brewers and to my students in a very concise format, very easily. Now, this is in the MBAA Technical Quarterly. So if you're not an MBA member yet, this is a good excuse to go get your MBA membership. It's wonderful. I can't recommend this enough. Now, full disclosure, we are involved in our local MBAA. We're a little biased on this. I think it's a great organization. One other thing we need to talk about before we get into some of the different types of tests, and this has to do with visualization and sign-off, understanding who actually recorded this data. This has to do with what we're going to be doing with this data or how actionable it is. Now, if you're collecting all this data and it just sits in an Excel spreadsheet and nothing ever actually comes of it, you're going to start having problems. If the data you collect is not actionable, why are you collecting it? People who are actually collecting the data will feel the same way. If I'm going to spend an hour doing this test and it's just for naught and nothing actually comes from it, why am I collecting it? So it's really important that we make this data we collect visualized. We have to make sure that it's observable. Now, this can be an Excel spreadsheet that you use or a little graph you see like this on the right-hand side. Visibility of the data you're working with and understanding why we're collecting it is very, very important. That's one part. The other one is sign-off. Every single action is done by someone. And if we don't know who did that test, we have no idea to how we can validate that data. If no one is willing to sign off and own that data, then the data starts becoming questionable. This is why having visualization and sign-off or ownership of the data is very, very important. Without these two, QC programs can start doing really well, but over time they will fade and wane. If no one's responsible for the data and no one understands why they're collecting the data tends not to be collected. We're not going to get into the psychology of things like that, but that's typically how it runs. Now, luckily for us, the previously mentioned paper by Tim Faith from the MBAA Technical Quarterly contains a beautifully laid out fermentation tracking sheet, which you see on the right-hand side. I highly recommend you check it out. Again, if this is an excuse for you to get an MBAA membership, I'm here for it. Now we'll get into the details for today. The first thing, I would recommend that you monitor all your fermentations in hours since yeast is added. Why use hours over days? This is pretty simple in my mind. Lots of fermentation can happen within a single day. We can have a beer go from 15 to 6 degrees Plato in a single day if we're working with a Kvike or even just an aggressive ale yeast. Utilizing hours helps us determine the minutiae and details of our fermentation. In my honest opinion, days are great for homebrewers, but we're pro-brewing here. Hours give us a lot of useful information, and they're a much better predictive measure of how fermentation should be going. I should know, say, within 48 hours, what my beer is going to look like, not 2 days. 48 hours is much more useful. Other one is tank type. You'd be amazed at the brewers that don't record this. Now, different tanks are going to have different fermentation kinetics. Example, a shallow, which would be a wide and short fermenter, will produce different beer in different flavors than, say, a thin, a skinny and tall fermenter. You need to know what different tanks are going to do and how different tanks are going to alter the performance of your different beers. As we also mentioned in Module 1, if you know that the tank closest to your brew house always has O2 issues, you need to flag this to remove it from the data set. I've seen an alarming number of breweries not record what beer the tank was. I was kind of shocked. Now, to give you an example on this, what we have here is two different fermenters, very different. On the left-hand side is a fermenter from a brewery called Diacetyl. Sorry if I'm saying that incorrectly. This is a wide, shallow fermenter. Now, on the right-hand side, we have these tall, skinny fermenters. These two fermenters, based on the kinetics, based on how the fermentation mechanically unfolds, are going to have different properties. How much CO2 is retained, how much pressure is on the yeast cells. These are all going to impact the flavor profiles produced. We need to make sure we compare apples to apples, not apples to oranges. We should not compare the ferment of a beer in the tank on the left to the beer in the tank on the right. You have to make sure this is accounted for. And another one that should be pretty self-explanatory, but there's been a few cases I can think of where this hasn't happened, and that's temperature. So why measure it? Now, put simply, higher fermentation temperatures will increase the rate of fermentation. Now, the inverse of this is also true. Colder fermentations will decrease the rate of fermentation, slowing it down. This is really important for us to know. If I have a beer that ferments at 20 degrees C, it is going to ferment faster per hour than a beer fermented at 18. So if we see that beer accelerate or we see the flavor profile change on that beer and we like it, we now know we need to hit 20 degrees Celsius. Without the data, it's really hard for us to tell. Now, we also see a big impact at the end of fermentation, especially due to the fact that the rate of fermentation decreases. We also see the heat generated by the ferment be minimized, and the environmental, say for here in Canada and for the winter, starts becoming much more impactful. We've seen a bunch of breweries have issues where at the end of fermentation, the colder temperatures lead to a decrease in attenuation, especially for high ABV beers. A lot of yeast strains, when they're stressed out in like 6 to 8% ABV and you put some cooling on them, whether or not it's from your glycol system or from the environment, they don't like it and they tend to go dormant earlier than you expected. Making sure you monitor temperature can help you adjust and help you understand what's going on. Another important one that I see brewers overlook a lot is pH. Now, many things in fermentation will alter the pH. In general, the pH typically drops from your wort of the low 5s to, at your beer, which is usually in the low 4s. Now, pH tends to drop quickly in the early stages of ferment, and there's almost no change to pH unless you do unless you alter the wort in some way. Once you get about halfway through ferment, once the yeast cells have hit their max concentration, you typically don't see a lot of alteration in pH. Now, there is a school of thought that you can use pH to determine when the end of fermentation is. I don't recommend this. I do not recommend this at all. Now, there are two things that we will see alter the pH of the beer once pH is kind of stabilized out in the low 4s. The first, an increase in wort pH, in beer pH, say we go from 4.2 to 4.4. This can actually be a sign of yeast autolysis. This is a sign that we should have removed our yeast from that beer earlier. If you ever see the pH of the beer start to increase right at the end, this is a sign that you need to remove your yeast from that beer ASAP. Another thing that will alter the pH is dry hopping. And what you can see right here, this is from the Goose Island paper I already previously mentioned, that whenever they dry hop, you see dry hop 1 and dry hop 2, they see an increase in pH. This is very common. We see this across the board for every single brewery. Dry hopping increases the pH of the beer. We're not going to go further into that. We're going to leave that topic there and pick it up maybe in a different lecture. Now, another one that might sound kind of silly, but gravity. obviously need to be checking our gravity. Now, the thing I want to emphasize here is when we should be checking our gravity. Key times to check in my mind would be 24 hours into ferment. If we do not see a decrease in our gravity within 24 hours, we know something has gone wrong. Same thing goes for 48. If I do not see a significant decrease in the gravity of my beer within 48 hours, something has definitely gone wrong. Halfway through ferment, if I know my beer at this point should have gone down 6 degrees Plato, it's currently gone down 3, serious problem. So why check these? Well, much like we talked about at the very beginning, we're trying to look at a proactive sorts of quality analysis. If I notice that 24 hours into ferment, my gravity hasn't really moved, I have options. I can decide to re-yeast. I can inject more yeast inside of this brew. I can apply additional oxygen to this beer to try and revitalize the cells that are already there. Same thing goes for 48 hours or halfway through ferment. The sooner I can generate data off this beer, and the more benchmarks I have, say I know my beer should go from OG to FG in 5-6 days. If I know what it should be, I know what the beer not being on track looks like, which means I can now intervene and fix this beer halfway through or earlier, ideally earlier. And finally, we need to know the end of fermentation. We need to know what our FG of this beer is supposed to be. If we have benchmarks, we should know what the FG should be. Now, I want to point one thing out, and this just needs to be said. Just because your gravity is stable doesn't mean your yeast cells are done fermenting. We have a handful of breweries who have this problem, where the beer is at stable gravity, but that doesn't mean the yeast cells aren't still doing a thing. And the thing they're typically doing at this point is diacetyl and acetaldehyde, or just other aldehyde reuptake, which we'll talk about next. Now, full disclosure on this topic, forced diacetyl testing, diacetyl testing is some of a favorite test of mine, so I'm a little biased on this. This is one of my favorite tests, but I do think it is one of the most important tests. The forced diacetyl test allows you to understand whether or not you have diacetyl or its precursor alpha-acetolactate present in your beer. Now, if you know you have these two, you can now make an informed decision. If you know you have these precursors, you can let your beer heat up. You can decide not to cold crash your beer. You can decide to mature that beer inside of your facility for a longer period of time so your clientele doesn't get diacetyl beer. Knowing this, doing this test, allows you to make informed decisions. Now, who should do this test? I would argue everyone should. It's cheap, it requires little or no equipment or experience. It's one of the easiest tests you can do. Now, we already have lots of content generated on this topic, and you can find the links to those videos down in the description. If you want to learn more about forced diacetyl testing or how to do this, we have lots of videos and lots of resources on that already. And one of the last things is just general sensory. There's a lot of breweries that don't know what their beer tastes like through the process. And this is something that I think every single brewery should do. You should know what your beer tastes like 96 hours into ferment. So here, let's go through a quick example as to why you would want to do this. If you know 96 hours into ferment, your beer should taste nice, fruity, with a little bit of diacetyl, and all of a sudden your beer does not taste like that, has a fusel alcohol note or something like that, you know something has gone wrong. Now, you may not be able to course correct as easily as at 96 hours, but if it's 48 hours or 24 hours into ferment, you can now make a much better, you now have the ability to react to this beer much sooner and potentially fix it, solve it, or increase its quality. Making sure you do the tests early allows you to make informed decisions to help course correct this beer to where you want it to be. Overall improving quality. Those are tests I think everyone should do. A test that I don't know if everyone should do, and I would usually argue no, not everyone should do it, are cell counts and viability checks. Important asterisk here, in ferment. I think every single brewery should be redoing cell counts before pitching, with rare exception. We'll talk, not without rare exception, but we'll talk about this more next lecture. But doing cell counts midway through ferment tells you three things. So say you do a cell count 24 hours into ferment. 24 hours into ferment, you should see all the cells you added inside a solution. So say I added 10 million cells per mil. I should see a cell count no less than 10 million cells per mil. If I don't, I know something's gone wrong. I know these yeast cells are sluggish. Maybe I didn't provide enough oxygen. Maybe I didn't provide enough micronutrients to these yeast cells. Maybe these yeast cells were stressed out. Maybe their NADH reserves were depleted. Something went wrong. 24 hours into ferment, I can now choose to add more yeast, re-aerate. I have options to do things. Now, we can also go through, if we do cell count, say 48, 96 hours, just further into ferment. We can see how much cells were grown. We should usually see roughly 4x the initial pitch we add. So if I added, say, 10 trillion cells, I want to see 40 trillion cells out on the other end. This will allow me to figure out if my cells operated how I expected them to operate. Really useful. And finally, let's tell me whether or not your cells have begun to flock out. Now, follow-up to that is, should they be flocculating out or stopping ferment now? If they're not, you can see the cells start to end ferment early, which then gives you the ability to react. Increase the fermentation temperature, add a bit more oxygen, maybe add some sugar to it. There's different options you can play with now because you know. So who should do this? This is a lot of time. It's a lot of effort. I don't necessarily think everyone should do this. Again, that might sound somewhat hypocritical, but you have to always take into account the time and energy you have available to you. Now, if tank time is important to you, now you know how the residency time or the center time of ferments is important to you. I absolutely think you should be doing this. Yes, you should be doing this because 12 hours for a large production facility is a lot of money. If I can remove that that beer from that fermenter sooner, 12 hours sooner, I can fill that fermenter 12 hours sooner, which is worth a lot of money. Now, if you're the opposite, where you have the ability to let the beer sit in the tank and clean up, then this test likely isn't for you. If you're not, say, hard pressed on production, yeah, you can probably get away with not doing this test. Not the best situation, but you have to use your time and resources accordingly. Now, a quick side note for this, and this is just a follow-up to the cell counts. Cell counts are effectively strictly quality control or a reactive test. They don't tell us much about this batch. Now, obviously, if we're 24 or 48 hours in, those do. Those will tell us a lot. If I know that 24 hours in, my yeast cells aren't doing what I want them to, that's proactive because I can fix it. What these cell counts really do is they tell us and inform us about further decisions that we can make. So we'll go into it. If my growth for my yeast cells wasn't where I wanted to, this likely means I have a low dissolved oxygen content at cast out. This likely means that I need to go look at that equipment and make sure it's operating properly. Something in that system probably isn't doing what I think it should do. Also, if I notice that my viability is lower than I thought it would be, say my viability is usually 90% at the end of ferment, or 85, 80%, whatever it is that you're seeing, and they're lower, this means that the cells are likely near the end of their life. They're likely too stressed. I likely don't want to repitch cells from this tank. These are two examples of being proactive in this process. We can use data generated on this beer to influence how the next beer is going to perform. Now, one other thing, just as a follow-up, we talked a lot in the first two lectures of this series in Module 1 that most breweries don't have a DO meter. I wouldn't say a lot of breweries do not have a DO meter. If you don't, using your growth and viability, mainly doing the cell counts, is a great way to help us infer whether or not your aeration system is operating as you think it is. If you see these get lower, this is an indication that your DO is not where you want it. Not direct, but this is a way for us to infer how much oxygen we're adding to our cells. Not ideal, but it's a way for you to make it work. And with that, we'll do some kind of wrap-up questions. Choosing the right tests. How do I determine what tests to do? We went through a handful of them. The easiest answer here is do what you can with the resources available. Testing needs to be sustainable. It does not make any sense to have tests being done, now and then for us to drop them 2 or 3 months later. It doesn't make sense. I'd recommend everyone complete gravity, pH, and temperature checks daily. I'd also recommend that you do a forced diacetyl test near the end of ferment and at cold crash to make sure that you're not going to have diacetyl issues in your beer later on. Question 2. So I'm doing these tests. What do I do now? Simple. You need to benchmark your fermentations. Look at the data sets for fermentation that produce beer that you were the happiest with and use those as the benchmarks to replicate. So here's an example. If 48 hours after fermentation, you want to see a 6 degree Plato decrease in gravity and a 0.4 decrease in pH. Those could be your benchmarks. Add 1 degree Plato plus or minus and 0.1 degree pH. You can now track whether or not your subsequent batches are doing what you want them to do, whether or not they're going to hit target. This gives you goals, which allows you to control your process to hit those targets. If you don't have goals, you don't have targets, you don't have any sort of anchoring, you're flying blind. Number 3, is pH really necessary? I get this one a lot where I go into a brewery and I realize they're having pH issues, but they don't have a pH meter. So I would argue that the answer to this is yes, pH is very important, but I fight with this answer for 2 reasons. The first one, if you don't have a moderate quality pH meter that is frequently calibrated, then don't use it. But you should really look at getting a higher quality one. A lot of the small little handheld ones, they're not very accurate. At least they're not very accurate for very long. It's not the best tool. You really do need a bench top, easily calibrate unit. There's no sense generating data that is not accurate or just kind of gibberish. And secondly, it's do the styles you're making rely on drinkability. Now, if you're making lagers typically prefer light lagers particularly. They like a lower pH. Lower pH makes them drier, crisper, enhances drinkability. While New England IPAs, on the other side, typically enjoy a little higher pH. The higher pH rounds them out, makes them smoother. It also makes the haze more stable. If you want to brew either of these beers that are really impacted by pH, it's really good to know. Now, I'm not saying that other beer styles don't benefit from knowing your pH, but they're not going to benefit as much. pH is not as critical of a control measure for them. I know that might cause some people to... I might get some pushback on that, and that's fine. Choosing the right tests, again, why not measure color? Go for it. You absolutely can. In general, you typically see a 3 to 6 degree SRM units of lightning between the wort and finished beer. This is caused mainly by pH shifts and precipitation of certain compounds and things like that. I didn't talk about it earlier because these typically require individual pieces of equipment that not all breweries have. Same thing goes for turbidity. If you want to measure turbidity, go for it. Makes a lot of sense. And one of the last ones, if you want more information on this, the goal today was to introduce you to a lot of topics. Now, we're going to be covering a bit more in depth these in sequential lectures. If you want more, I cannot recommend the paper by Tim Faith of Goose Island more. And if this is the excuse to get the MBA membership, I'm here for it. Oh, and finally, yeast cropping. What about yeast cropping? That's kind of a big thing, isn't it? This is the focus of the next lecture. We're going to be looking at how to yeast crop, when in your process to crop yeast, what impacts flocculation, and then finally yeast brinks. Now, I want you guys to all be aware this is the next lecture on this series is not going to be the only time we talk about this. We have a series of blog posts on yeast brinks and other methods for cropping that I'm going to be following up in the next couple months. So look forward to those too. And with that, that's it for today. Thanks everyone for taking some time. Hope you learned a lot, and happy brewing. Cheers.